Hey guys, welcome back. It is me once again, Coach Campbell, your physics teacher. So today we're going to go look at the impulse assignment that we had from this week. It says calculate the impulse in each example. Unfortunately, what I noticed after I made this assignment, is that I did not include the main formula for impulse. Or part of it's right here, but the big deal for the first page pretty much is mass times velocity final minus mass times velocity initial. Okay, and that's going to be a big help as we go through this. Calculate the impulse in each example. Okay, so impulse is change in P equals mass times velocity final minus mass times velocity initial. In this case, our mass is 1 kilogram, and that doesn't change. So we know that we're going to have 1, you can put 1.0 if you wish, each time we have the M. Okay, so I'm entering, just a second guys, pause. All right guys, welcome back. I am going to finish up this problem. We have mass times velocity final minus mass times velocity initial. The final velocity, what went from rest, it went from rest, so is that initial or is that final? That's initial, that's VI. Okay, to positive 10, that's our velocity final. So velocity final goes over here under the VF. Velocity final is positive 10 minus mass velocity initial. From rest, 0. What we get is 1 times 10 is 10 minus 0, sure, equals, we have 10 and kilogram meters per second. That's it. A 1 kilogram clay ball. Now, again, the same deal. I'll put the formula MVF minus MVI. Okay, down at negative 10, then hits the floor and sticks to it. If it hits the floor, that means the velocity final is 0. This is our velocity initial. Okay, so our mass is 1.0, sure. Velocity final, what do we say? It's stuck to the floor. Velocity final is 0 minus mass 1.0 times velocity initial. It was going negative 10. Okay. You can put J if you want to for impulse, either way, or triangle P. Okay, 1 times 0, anything times 0 is 0, minus, well, we've got 1 times negative 10, that's negative 10. 0 minus a negative, careful, it's not negative 10, gives us positive 10. Okay? A super ball going down, hits the floor, then bounces back up at positive 10. Okay? Pause it, try it. See if you can do this one on your own. I'm going to continue forward. 1.0. Velocity final, it's bouncing back up. So the final is 10 minus 1.0 times velocity initial. Initial velocity, it was going at negative 10. Okay, 1 times 10, simple math now, right? 10 minus 1 times negative 10, negative 10. 10 minus negative 10 is positive 20. Next one, a 1,000 kilogram car slows down. It's slowing down. So if it's slowing down, I think that our final impulse should be negative. So we'll see. 1,000 kilogram car, let's write the equation. Final minus initial. Mass is 1,000 times velocity final. Well, what's it doing at the end? Hey, you should have put 20 minus 1,000 times 30 was going initially. Okay, looks like we got 20,000 minus 30,000 equals, if we type that straight into the calculator, we get negative 10,000. Okay. Number 2, a 1,500 kilogram car going east positive slows to a stop in 5 seconds. What impulse acts on the car during this event? Okay. Asking impulse again. Same deal. I encourage you to pause it and try this one all the way through. Mass, 1,500 times velocity final. What's our velocity final? Well, it's slowing down to a stop, right? velocity final is 0 minus still 1500 times initial velocity was going positive 20. East is positive. Okay. Type that straight into your calculator, and we get, I believe, 30,000. Let me confirm. Yep, there we go. 30,000 negative. What's the direction of the impulse? Well, we got negative. Positive was east, right? It was going east. That's positive. Negative would be west. What is the magnitude of the stopping force? Remember from before, we learned force is equal to change in P over change in time. Okay? You could do it as J over T. Well, we found that J was negative 30,000. Divide that by time. Time was 5 seconds. So I believe we get negative 6,000. And force is measured in newtons, okay? Which set of unit is correct for impulse? Kilogram meter squared second squared? No. Newton seconds? Yes, that is one of them. Kilogram meters per second? Definitely. Kilogram meters per second squared? No. Okay, so it's got two separate units that we could possibly use for it. Okay, we would use Newton seconds if we multiply. Actually, this one's not right. I'm sorry, guys. It would be Newton seconds in S, not in over S. That's my bad. If it said in S, it would be correct, but it says in divided by S. It's not newtons per second, it's Newton seconds. So only this one ends up being right. Cool, let's go on to the back side. There are many ways to produce the same impulse. Which of these does not produce the same impulse as the others? Okay, remember that we can find impulse by multiplying force times time. In this case, a 400 newtons times 0.6. In this case, 200 times 1. In this case, 1,000 times 0.2. In this case, 500 times 0.4. Okay, so 200 times 1, let's do the easy ones. 200 times 1, that's 200. 0.2 times 1,000 is also 200. And 500 times 0.4 is also going to give us 200. 400 times 0.6 is not. I believe that gives us 240. Okay, so which one of these is not produce the same impulse? A. Okay. Airbags can save lives in a collision. Which one is true? An airbag reduces the impulse on a passenger. No, it doesn't reduce the impulse because our change in momentum is still the same. Airbag increases the length of the time the collision lasts. Definitely, yes. Airbag absorbs the impulse that the passenger would have experienced. Know that a passenger would have still experienced the same impulse because impulse is change in momentum. If he was going 40 and then he stops at 0, right? 40 miles an hour stops at 0 miles an hour. That is an impulse, no matter how fast it happens. The airbag doesn't change how fast that happens. The airbag increases the average force on the passenger. Increases the force? No, it decreases the average force. So that one's wrong. Okay, number 6. Moving on. A 5-kilogram cannonball is dropped from the top of the tower, falling for 1.6 seconds before slamming into a sand pile. Cool. What is the velocity of the cannonball just before it hits the ground? Oh man. So this one involves free fall motion. I'm going to just say let's ignore that one. But if you're curious, on how this one would work, if it fell for 1.6 seconds, we would multiply 1.6 times 9.8 to give us the speed just before it hits the ground. You can skip ahead till it gets to number 7. But that's how you would find the speed. 1.6 times 9.8 is 15.90. I'm sorry, 68. Okay, 1.6 times 9.8 is 15.68. That's how fast it hits the ground. It's actually going negative. What is the velocity of the cannonball? Negative 15.68, just before it hits the ground. Meters per second. What's the impulse and the direction? I'll let you all solve that one if you want to go above and beyond. Okay. Number 7. Let's make sure that it's nothing like that. A 10 kilogram rocket is traveling at 80 meters a second when the booster engine applies a constant forward force of 60 newtons for 3 seconds. Impulse, J equals F times T. In this case, 60 times 3 is 180 kg. Oh, it's force and time, so this is Newton seconds. My bad. What is the resulting velocity? Okay, the resultant velocity. So here's how we do that. We know that change in P is mass times velocity final minus mass times velocity initial. In this case, we know that our change in P is 180 equals mass of the rocket is 10. So we put it in underneath both the ends. Velocity final, resulting velocity, that's what we're finding. Minus 10 times initial velocity is initially traveling 80. Okay, so we have 180 equals 10v minus the 800. Okay, so we need to get rid of this minus 800 and add it. So we have 980 equals 10 times whatever velocity resultant is. Okay, you can do the simple math there. You find that the velocity is 98 meters per second. By simple math, I mean you would divide both sides 10. Okay. All right, guys. Hopefully this video helped you in your endeavors to understand how impulse works. If not, then find some videos online that discuss impulse. Okay. Good luck on your test if you have not taken it already. I will see you later. Goodbye.